All right, welcome back. Today we are going to be working on 7.5 Day 1 notes. We will be talking about factoring trinomials. All right, let's first start by talking about what we know. In the last video, we factored by the GCF. Let's look at example 1. You should recognize that both terms are divisible by 2. That means I'm going to divide both sides by 2. And since I'm dividing by 2, I go on the outside. And I divide everything by 2. 2m divided by 2 is m. Negative 18 divided by 2 is negative 9. And that is how we factor by the GCF. Now remember, we can always check by redistributing. 2 times m is 2m. 2 times negative 9 is negative 18. Is that matches the original question? We know we got the answer correct. All right, let's go on to example number 2. When you're looking at number 2, you should recognize that both 3 and positive 27 are both divisible by 3. And they also share another thing in common. Remember, we choose the smallest exponent. So between m squared and m to the first, the smallest one is m to the first. My GCF would be 3m. Remember, 3m always goes on the outside. Always the GCF goes on the outside. Now we divide. 3 divided by 3 is 1. M squared divided by m is m, because the numerator wins by 1 because we subtract that. And then 27 divided by 3, positive 9. There's a tie with the m's. All right, and lastly, looking at example number 3, you notice that they all share in common with an x. Remember, x cubed, x squared, x to the first. We always choose the smallest exponent. So my smallest exponent is x. X comes outside. Now I'm going to divide. X cubed divided by x. My numerator wins by 2, because that's technically x to the first. So I have x squared. Here, my numerator wins by 1, because it's between 2 and 1. Plus 4x. And lastly, x divided by x, there's a tie, but I still have to bring down the positive 1. Just like 5 divided by 5 is still 1. You still need to drop down that 1. What we are going to learn how to do today is we're going to start with a trinomial, and I'm going to factor it into the two binomials. Remember, we can also check this because we can go backwards by distributing to get to the original question. All right, no matter what, we still have to check to see if we can factor out a GCF first. That is always our first step. So always see if all of the terms are divisible by the same number or same variable. If so, factor that out and then continue the process what we're going to learn today. All right, what we're going to learn how to do is factor x squared plus 7x plus 6 into the two binomials that originally multiplied to it. The first thing you're going to do is write out all the factors of x squared. Well, the only way to make x squared is x times x. Then you're going to write out the factors of the third term. So what multiplies to 6? Well, it's 1 times 6 and 2 times 3. Now you have to pick what combination works. And I'll tell you how you know it works. You want to know which combination, 1 and 6 or 2 and 3, that they're going to add in the middle. Well, if you recognize 1 and 6, when you add them, you make 7, which that's what we wanted. So here's the first one. Well, I'm going to have x first in both parentheses, and that came from this right here. Now I'm going to have a plus 1 and a plus 6. And that is how I factor it. Again, we could check to see if we got this right. We check by redistributing. So I'm going to distribute x plus 1 times x plus 6, and I'll see if I get the original problem. So I have x times x squared. X times 6, positive 6x. 1 times x, positive x. 1 times 6 is positive 6. my middle terms, x squared plus 7x plus 6, which is exactly what I started with. So again, you write out the factors of the first. That is what goes on the first part of the parenthesis. Then you write the factors of the third term. What multiplies to 6? 1 and 6, 2 and 3. From those combinations, you choose the combination that adds to your middle term. So that is why we chose 1 and 6, because 1 times 6 is 6, but also 1 plus 6 is 7. The 1 and the 6 goes in the second term. It does not matter the order. So again, you could have x plus 6 times x plus 1. They are the exact same answer. Order does not matter. All right, let's go ahead and try example number 2. Again, we should always check to see if we can factor out a GCF. I cannot factor out a GCF in example 2, so let's get started. What makes x squared? X times x. And I move to the third term. What multiplies to positive 8? Well, 1 and 8, 2 and 4. From these combinations, I have two combinations to choose from. I need to pick one that's going to add to negative 6. That's the problem. 1 and 8 obviously aren't going to work because they add to 9. 2 and 4 adds to positive 6. I want negative 6. So hopefully you remember your properties with negative numbers. A negative times a negative still will make a positive 8, but now it will add to negative 6. So my two binomials are going to be x minus 2 and x minus 4. Again, we can go ahead and check that by redistributing. Again, I repeat, when I have two numbers that multiply to positive, they're either both positive or both negative. That's the only way I can multiply two numbers to get a positive number. So therefore, since I needed to add to a negative number, I multiplied negative 2 times negative 4. That now adds to negative 6. All right, let's go ahead and do some examples. Let's go through number 1. Again, no matter what, you always check to see if you can factor out a GCF. 1, I don't see anything that I could factor out. I'm going to go ahead and get started. What makes y? What two terms multiply to get y squared? Y and y. Again, I'm going to write down everything that multiplies to 21. Let's start with the easiest. 1 and 21. So you can have 2. In your calculator, you would do 21 divided by 2. Nope, doesn't work when you press enter. Now you go to 3. It does. 3 and 7. And those are the only two terms, only two combinations that multiply to 21. Now, we have to choose the combination that's going to add to negative 10. If you recognize 3 and 7, when you add that, you get positive 10. Remember the last example, to make them both negative. Now we'll add to negative 10. It still multiplies with positive 21. And I factor out y minus 3, y minus 7. Again, the order doesn't matter. You could have the negative 7 first and the negative 4. All right, example number 2. Again, always check for GCF. You cannot divide everything by x because a 36 doesn't have an x to begin with. From here, what two terms multiply to x squared? That's still x. Now let's go ahead and multiply, write down all the numbers that multiply to 36. Let's start with the first one. We have 1 and 36. Now your calculator do 36 divided by 2. So I have 2 and 18. Now check 3. In your calculator, you do 36 divided by 3. Oh, it works. 3 and 12. Now we're going to go ahead and try 4. So in your calculator, do 36 divided by 4. That also works. 4 and 9. 5 wouldn't work. 6 would work. 6 and 6. 7 wouldn't work. 8 wouldn't work. And those are all the factors. From all the combinations, you want to figure out what combination will add to positive you recognize 2 plus 18 is positive 20? Now I don't need to make both of them negative because I need them to add to a positive 20. So my factors are going to be 2 x plus 18. And again, the order doesn't matter, so the positive and negative come first. All right, example number 3. Again, always check for a GCF. Again, we can't divide everything by a W because that negative 21 doesn't have a W to begin with. Let's start. I'm going to factor out my first term, W squared. Two terms that W squared are W and W. Now I have to write out the factors of a negative 21. So in order to be a negative number, one number is positive, one number is negative. So we have negative 1 and 21. So one of them is negative. And I have negative 3, positive 7. All right, so now I got to figure out between those two combinations which one adds to positive 4. You should recognize right here. Because negative 3 plus 7 is positive 4, and that's my combination. I have W minus 3, W plus 7. Now, for example, what about if you wrote negative 21 and you had the negative with the 7 instead of the 3? Well, 3 minus 7, that would equal negative 4. But since we want a positive 4, that's an easy mistake to fix. We're just going to flip-flop where the negatives are. So that might happen in your homework or the next couple of examples. All right, let's go ahead and do example number 4. Again, always check for a GCF. There's not anything that I can divide all three terms by. So let's go ahead and write the factors of n squared. It's just n and n. Now I'm writing factors of a negative 24. Remember, when I write factors of a negative number, one number is positive, the other one is negative. Let's start. Negative 1 and positive 24. Negative 2 and positive 5. Negative 3 and positive 8. Negative 4 and positive 6. Again, I'm getting these numbers, so I'm just checking with my calculator. Negative 24 divided by 1. Then I divide by 2. Then I divide by 3. Then I divide by 4. And then I realize I can't divide by anything else. So again, I'm looking for one of these combinations that adds to negative 2. Well, this one is almost right, but look, when you add it in your calculator, negative 4 plus 6, that equals positive 2. I don't want positive 2, but again, that's an easy fix. We flip flop where the negative sign. Now when we add it, positive 4 minus 6, that will now equal positive 2. Alright, so my combination is going to be n plus 4 plus n minus 6. And we can always check that by redistributing. Alright, example number 5. Then always check for a GCF, but there is nothing that I could divide r squared, 13r, and 22 by that are equal to 1. So I'm going to start. What makes r squared? Well, that's just r and r. Everything that makes a positive 22, 1, 22, 2, and 11. Now between these two combinations, you should recognize that 2 and 11, add them, makes 13. So I don't have the correct combination. It's r plus 2 and r plus 11. All right, number 6. Again, always check to see if you have a GCF. Number 6, I do not. All right, x squared, I factor that to x and x. 16, everything that multiplies to 16. 1, 16, 2, and 8. 4, and 4. I have to pick the combination that adds to -8. Well, this one is pretty close, but you should recognize when I add 4 and 4, that makes +8. I want -8. So that's an easy fix. They're either one's going to become negative or both of them's going to become negative. Since this is positive, it needs to multiply to a positive number, so that means both of them go negative. From here, my factors are x minus 4 times x minus 4. All right, again, you should be asking yourself the first question, can I divide by a GCF? And the answer is yes this time because everything is divisible by 2. So divide everything by 2. And I'm going to bring the 2 out in front. I'm left with b squared plus 11b plus 28. Now, normally, from what we've learned in the last lesson, we cannot normally go further, but we should check the leftovers, meaning everything in here. Let's see if we can check further. You always need to check. So b squared, b times b, everything that multiplies to 28. 1 and 28, 2 and 14, 4 and 7. I'm going to stop right there because look, 4 plus 7 equals 11. So those are the factors. What you got to be really careful about is that 2 that we factored out to begin with must keep drafted down. Now I write my factors. B plus 4 times B plus 7. The mistake is people forget to drop down that 2. All right, let's go to number 8. Hopefully you recognize that all 3 terms are divisible by 3. So again, I do have a GCF for this one, 3. I'm going to take that 3, bring it on in front, and I'm going to divide. I'm left with x squared minus 6x plus 9. Again, I'm going to check to see if I can factor further. X squared makes us an x, and positive 9 makes 1, and 9, 3, and 3. I'm looking for which combination adds to -6. Both 3 and 3 make +6, but again, that's an easy fix since it multiplies to a positive number. Both of them become negative. And be very careful, the 3 that you pull down, keep dropping it down. And then my factors are going to be s minus 3 times s minus 3. All right, number 9. Again, this one does not have a GCF, so it's different than 7 and 8. So I'm just going to go ahead and start a factor. P squared becomes p times p. And the only numbers that multiply to 5 are 1 and 5. You should see that we're running into a problem. To say 1 plus 5 doesn't make 7. There's no way. -1 times -5 makes 5, but when we add that, it equals -6. So not every trinomial is factorable. So number 9 is not factorable. So when you cannot find a combination, and there's no numbers that multiply to 5 but also add to 7, they are not factorable. All right. Let's go ahead and do 10. Again, you should always ask yourself, can I factor out a GCF? And the question answer is for number 10, yes, you can. Everything is divisible by 5. We're going to bring down the 5. I'm left with m squared minus 2m plus 1. Always check to see if you can factor further. Let's check. M squared, I factored into m and n. And the only two numbers that make 1 are 1 and 1. Again, I'm looking for combinations of 1 that add to -2. Be careful, 1 plus 1 is +2. But again, that's an easy fix. They both become negative. Again, don't forget on that original 5 that you pulled out. And my factors are going to be m -1 times m -1. All right, number 11. This is a problem that we did on the last video. You should always check for a GCF. Again, so let's look between 27 and 3. You should recognize that 3 can go into both of them. We choose the smallest exponent. Remember, a to the 5th, a to the 4th. The smallest exponent is a to the 4th. Lastly, b squared and b to the 1st. Again, the smallest one is b to the 1st. So b. Put that GCF on the outside. Now we divide. 3 divided by 3 is 1. A to the 5th divided by a to the 4th. Numerator wins by 1. B squared divided by b. Numerator wins by 1. Minus 27 divided by 3 is 9. There's a tie with the a's and a tie with the b's. Again, I can't factor further down here like I did over here after I pulled up the GCF because I'm not left with a quadratic, meaning the exponent is not 2. So this would just be my final answer. All right, and number 12. You should always check to see if you can factor out a GCF, and you can. So my GCF is 3. Again, pull out 3 out in front. I'm with g squared plus 7g minus 8. Always check. See, now my leftovers, I'm left with a quadratic. Different from 11, I was not left with a quadratic. So when you're left with a quadratic, always try to factor further. G squared, g times g. Now everything that makes a -8. Remember, in order to make a negative number, we have a positive and a negative in each combination. So let's say -1 and 8, -2 and 4. Which of these combinations add to +7? Say -8 and +1. That's the combination. So, oops, sorry. So here, again, don't forget to bring down that 3. And my factors are g minus 1 times g plus 8. All right, please go ahead and complete the following homework assignment.